Okay, this is an introduction to energy for chemists. The kind of questions we'll be asking are, where does electrical power originate from? We'll compare various power generation systems. It sounds dry enough, but it's a very important question for the future. Should we go with fusion-based power, fission-based power? Should we continue to burn coal? How should we get our energy in general? So this is Screencast 12.1. And let's go ahead and begin. Alright, welcome to planet Earth. We've got various types of primary energy sources available. Our deluxe meals include this one here with a big pile of coal. Another one here with a black smoke. They usually burn this at night so you don't see it. This is an oil-based power plant. Perhaps you recognize this one. Lots of pipes available. This is natural gas, which is primarily methane, CH4. Here's one with also a lot of piping into it. This is a converted power plant. A lot of these in Connecticut. These burn biomass, essentially dried garbage. And at our homes here in the Northeast, you'll see a lot of wood stoves. The cost for each of these is considered generally to be high. The reason? Chemical reaction is all based on burning hydrocarbons, regardless of the source here. And the generalized chemical reaction is a combination of carbon and hydrogen is oxidized or combusted to produce carbon dioxide and water. And carbon dioxide is the main culprit here. This contributes to global warming, etc. We do, however, have some specials. This is a device you're probably familiar with based on nuclear fission that's been around since the 60s, I imagine. Here's a device that doesn't exist yet. Here it is in a science fiction movie. Here it is in real life as it exists in California. There's also versions of this being produced in Europe. These are nuclear fusion devices. You can learn more by clicking here or going to the last slide in this unit. The cost to the planet, well, let's write medium for now. People worry about what to do with nuclear waste here. They're not sure what the problem will be here, but I'm sure one will crop up. Very exciting devices for the future, however. The chemical reaction, that's the misnomer. It's a nuclear reaction, so you might want to cross that out and write nuclear process. It involves bombarding uranium-235, which is relatively difficult to isolate, with a neutron to generate a very unstable nucleus in uranium-236, which will then decompose to undergo to smaller atoms, including the ones shown there. Those neutrons go on to bombard uranium-235 again, and you can see that this is a chain reaction. For nuclear fusion, it's a very different process. We simply combine two different isotopes of hydrogen, shown here, tritium and deuterium, other ones can be used to make simply helium, so it's a very different process. Important to note, neither of these are chemical processes, they are nuclear processes. Transmutation, we're making new elements. We do also have nice items in our value menu. These are very popular. This one you might not be familiar with, but it's an attempt to use the energy present in the ocean. And here in Connecticut, this is a definite viable possibility, although you don't see any of these things around. Wave energy. Propellers, absolutely. For wind energy, you're seeing more and more of those. You saw a lot of these in the 70s, not so much anymore, however. Perhaps you'll see more as time goes on. Solar energy. These ones are very exciting. If you drill holes into the ground, you can generate some geothermal energy. This is an oldie but a goodie. Hydroelectric power. Cost to the planet? Well, these are our dollar items. Okay, the chemical reaction in these cases is none. We're simply converting different forms of energy which already exist. Do they generate the huge amounts of power that we as humans need? Think about that and place your order. If you had to choose one of these, which one would it be? This is Screencast 12.1.